example of a graph database on a conventional cluster where each block represents a server in the cluster. Traversing a graph causes data accesses to be out of order, which in the case of conventional clusters means that they cannot take advantage of CPU cache for local performance and are hit with the same wasteful four-way packet communications for each remote access as clusters in general. In the case of graphs, the irregularity comes because vertices are linked to other vertices that can be anywhere in the distributed cluster. In a cluster, accessing a vertex requires using MPI to send a request to the server with the program, shown here in dark blue, to get to the next vertex, wait for it to arrive, then examine that vertex to get to the address of the next vertex, and repeat. This means that network bandwidth is heavily used and execution is slow. The 3D grid here represents vertices in a graph which are distributed through a single scalable shared memory. In Lucata's system, we simply move the program context, or thread, to the node which contains the next vertex. It's a small, one-way trip for the program context to move to where the data is stored. The dataset resides in a shared pool of memory, so only the program context moves from memory to memory, resulting in better usage of the network. Our small packets have no wasted bytes, only travel one way per access as compared to 4 for a cluster, and consume only 48 bytes per packet over the network. The key advantages are that tiny program contexts move across interconnects instead of large data chunks. There are no wasted bytes moving program context, and Lucata uses only 1/20th the network bandwidth of a traditional system. Thank you for taking a brief look at how Lucata's technology converges compute and memory architectures to solve the next wave of big data, artificial intelligence, machine learning, and application problems. To learn more about our innovative, scalable technology and how it can help solve your big data analytics problems, visit lucata.com.